Hey everybody, this is Mr. Munson, and we're in Unit 6, G.6, and we're looking at similar figures. And so with these similar figures, this section, G.6.3, concept number 3 in your student learning map, you'll see that we're going to be talking about similar triangles and shortcuts to doing this, okay? So we're going to be looking at a picture like this at the very end and seeing if there's some way that we can create an answer for how tall this tree is. And it's going to have something to do with similar triangles. Let's get started. All right, so remember this section, this unit that we're working on is similar figures. In chapter 5, we looked at congruent figures. And so at the beginning of chapter 5, when we were talking about congruent figures, we said, hey, to show that figures were congruent, I had to look at the two figures. Let's say it's these two triangles. I had to look at these two figures and say, hey, for every angle here, let's say this was 35, there had to be an angle 35 down here someplace. And if this one was 78, there had to be a 78 down here. And of course, these would be congruent by vertical angles. Or if this side was a 7, then there had to be a 7 down here someplace else to match up with it, okay? And so most likely it would have been here. And so if this would have been 5, there had to be a 5 down here that matched up with it. And so for the 3 sides up here, there had to be some evidence that all 3 sides existed here, exactly the same. And for the 3 angles over here, that there existed 3 exact angles down here. And that's how we started off chapter 5, saying, how do we prove figures are congruent? We have to prove that every angle here has an angle down here, and every side up here has a side down here. And then we got to got to the idea of triangles and said, wait a minute. We don't have to show 3 sides and 3 sides and 3 angles and 3 angles. There's actually shortcuts that forces the triangles to be congruent. And one of them is just show 3 sides up here, match 3 sides down here. That's side, side, side. Or maybe show that a side, an angle, and a side are congruent to a side, angle, and a side, and that side, angle, side. And then everything becomes congruent, right? All the pieces start to become congruent, their corresponding parts. And so we had these 5 shortcuts. And then we also had 2 that didn't work out so well for us. Let's just remind ourselves real quickly how we used congruent triangle shortcuts. The reason is because we're going to have some similar triangle shortcuts that we're going to learn in this video. So the idea is the same, but the results are different. I'm talking congruent triangles here now on this page, but beyond this, we're going to be talking about similar triangles, meaning one is actually not congruent to the other, but one is a smaller size than the other. Okay, so let's take a look at the given information, but first I'm going to go ahead and mark what came for free. That's vertical angles. Remember, I can't mark anything congruent unless I have some reason to do it. Okay, so AB is parallel to ED, and sometimes there's a mistake there. Students will think that means that they're congruent, and that's not true. It's just simply that they're parallel. But that parallel does do this for me. Let me draw this Z for us. So that Z is created by that parallel lines and that transversal. It goes through those parallel lines. And what that does for us is it creates some congruent angles. So the angle that's in this crux of the Z is also congruent to that one. Now the same thing is true in this case, that if I drew the Z going this direction, then those 2 angles would be congruent to each other. But I don't need those. Because they tell me C is the midpoint. C is the midpoint of BE, and all that's telling me is that these pieces here are congruent to each other. C is in the middle, so it cuts it in half. Okay, well, I learned my chapter 5 pretty good, and so I can see that there's a side or an angle, side, angle. And so that's an angle, side, angle situation. And so now I conclude that those 2 triangles are congruent. And if that's congruent, then that means this angle and that angle are the same. That means this side and this side is the same, and so on. And when you start hearing that they're the same, that's giving me a hint of what kind of equation I could write. If I had numbers involved in this, I could set those things equal to each other. Now in this problem, I'm asking you, are these 2 triangles similar? Now I could show every angle matches up and every set of sides, every pair of sides, corresponding sides are proportional. I don't want them to be congruent. Remember, I want them to be proportional. That means one's going to be slightly smaller than the other. So we first of all just confirmed that we're dealing with the same number of sides in both the figures, and we are. So we could go and try to find all the angles or find the sides in right proportions and see if anything fails out on it, okay? Let's just kind of start here and do the sides, okay? So I now know that this is congruent to this, so I can put a 12 here. And this, even though it doesn't look like a right triangle, that's 90 degrees, and so I can use Pythagorean theorem to find that side. Let me just tell you that it's going to be 12 squared roots of 2 after I'm done doing the Pythagorean theorem. Okay, so now I can take the sides and write proportions between them. Now, you're probably catching the obvious problem here. This side and this side are the same, and there's no two sides over here the same. And that's a screaming information that hey, these two triangles are not similar. But let me just go through the artwork so you know how to do it on other kinds of problems. Let's pretend like this 12 goes with that 12. Those two wrap the 90-degree angle, right? Okay, and then we'll take this other side of the 90, 12 squared roots of 3, and write it over its partner of 12. And there's your problem. This is going to be 1 when I do the division. This one is going to be 1.73. Now, there's another set of sides, 24 and 12 squared roots of 2. And I could take the time to write this and put it in my calculator, but what I want you to know is you've already had it fail here. So I just know from this first set, these two triangles up here are not similar. And that's how you work the sides, right? Okay, let's just, for the fun of it, look at the angles. Let's, just for the case of trying to figure this out. Now, these two sides are the same. That means these angles are the same. And I, therefore, conclude those have to be 45-degree angles. And there's the problem there. There's no 45-degree angles over here. So it also would fail in the angle category. So let's get to the meat of the act of this video. In 6.3, similar triangles, I want to tell you about some shortcuts. Instead of having to check everything, all I want to do is look for some shortcuts, okay? So what ends up happening is that if I have 3 sets of sides in a triangle, so here's one triangle to the left and one triangle to the right, and I take the 3 sides, the small, match it up with the small, and I take the medium and I match it up to the medium and the large to the large, and I find that those 3 fractions all are equal to each other. Now remember, they might not look equal, but once I turn them into decimals, if the decimals are the same, then I'm good to go. Now, if all 3 of those fractions equal each other, then we find that the 3 sets of sides are proportional, and we conclude that the figures are similar. Okay? Now this is called the side-side-side similarity. And very important, when you write this shortcut, you have to put that little similarity sign after it. Let me teach you another shortcut. Angle-angle similarity. In other words, if I have 2 sets of angles that are congruent, such as this, then I know I can conclude that these triangles are similar. Now that's very powerful in both those cases. And this is in all cases, if I find that triangles are similar, then I now know their angles are congruent, their matching angles are congruent, and their matching sides are proportional. So that's giving me a hint of what kind of equations I can write. Hey, this angle is equal to that angle because, well, they're congruent. All right, let's take a look at another one. Side angle side similarity. Again, I can't express this enough. A lot of times students leave off this mark, and I'm forced to count points off or count the problem completely wrong, especially on this one. If you leave this one off here or here, then you're saying side angle side, which is already the script for saying that triangles are congruent, and we don't mean for them to be congruent, we want them to be similar. Okay, so what this is saying is this. Suppose I had 2 triangles, and I had a pair of angles that are congruent. Remember, we're never talking about angles being proportional. We're always talking about sides being proportional. So I have this pair of angles that are congruent. And then when I take the sides, and I write ratios between them, and I find that those ratios are equal to each other, then what I find is that the two sets of sides are proportional and the pair of angles are congruent. When I have this scenario, then I conclude that the triangles are similar. Okay? Very good. All right, let's take a look at the problem to the right, or to the left. I have two triangles here, and I'm wanting to know if they're similar. So if I can prove it through one of these shortcuts, that will be just dandy. All right, well, I know that this angle here is 35 because of vertical angles. I always have to have a reason for marking angles congruent or sides congruent or whatever. Okay, I'm thinking I might go for the side or the pair of angles that are congruent. I don't know anything about the sides, so that's a hint. This kind of requires the side information. This one just requires two angles. So I've got one pair of angles that are congruent. The problem is I don't have a 45 in the left and 100 for the right. Now I can use the triangle sum theorem to find that angle there. Let's do that. And after doing that calculation, I find that that's 45 degrees. All right, there you go. I got an angle congruent to an angle congruent to an angle, and by angle-angle similarity, these triangles are similar. And there you have it. Now let's move over to the right one. All right, so I'm looking to see if these triangles are similar, and then it says if they are, then go ahead and write an equation and solve for the y. All right, let's check to see if one of these exists. So I have a right, and then I have two sides that wrap it and two sides that wrap this right. I'm starting to think that this might be a good one to go test. I have a pair of right angles. That means I have the middle angle congruent to each other. Now I just need to check to see if the pair of sides that wrap it are proportional. Okay, I want you to go ahead and write a relationship, a fraction equals another fraction, and see if you can figure out which sides here belong with these sides over here. Put me on pause and come back and check your work. Now, I'm hoping you found that easy because 3 is the smaller of the two here, and 12 is the smaller of the two here. So I know to match those up. That's my logical idea. Now, after doing those calculations, dividing the two numbers, I find that they're exactly the same fraction, the decimal equivalent, right? They're both the same. So since the sides that wrap them are proportional, then I conclude by side angle side, these triangles are similar. All right, let's take a look at these two. It's asking if the triangles are similar, and if yes, by which, why. And just like in the world of congruence, when we were trying to prove triangles are congruent, we had to state the reason why. It was always one of these shortcuts. Okay, so I'm seeing three sets of sides known and three sets of sides that are known. I don't know anything about the angles. So that's giving me an idea. I might want to check using this method. That means I'm going to write a ratio between corresponding sides here, one set. And then I'm going to write another ratio between corresponding sides here and another ratio between two corresponding sides here. And then I'll just check to see if these ratios are equal. Just turn them into decimals and see if they're the same. All right, go ahead and put me on pause and see if you can match them up correctly and set those up. Come back and check your work in just a moment. Put me on pause. All right, well, those are the fractions I got. Now, once I took them and turned them into decimals, I got 0.02 or 0.2 for all of them. And that tells me that these are proportional. Now, how did I choose to put 7 with 35? Well, if you take a look at my notation, something that helps me kind of get things organized. This is the small, medium, and large sides, and so on over here. So I just matched the small to the small, and the medium to the medium, and so on. Well, here's the problem I talked about at the very beginning. I'm asking, are these two triangles similar? And if they are, state the reason why, and then find x. Now, the very first thing is you're going to have to be able to see two triangles. Well, here's one triangle. Right? There's one triangle. Here's another. Very good. Now I'm wondering if those two triangles are congruent. And if I can prove that they are, then they're similar, which means that their sides are proportional. That will help me solve for this x. Now, before I get too far, I just want to remind us where we pulled these from. Okay, so there's one triangle, and here's the other triangle. Notice that these two angles here are the same angle on both the triangles. And by the reflexive property, here we're using it for angles, whoops. Um, by the reflexive property, these two triangles are similar. Okay, now don't worry about the changes in the shape, but that's just the program doing that. So I get to mark those angles being congruent for free. Those are not vertical angles, but that's something that we're going to have to recognize as always being a pair of angles that are congruent. They're like vertical angles in the sense they come for free. Another set of angles that we sometimes fail to forget to see is that a tree stands upright, so that forms a right angle. And I stand upright most of the time, and that forms another right angle. So now I know by angle similarity, these triangles are similar. And that means that the sides are proportional. That's an idea for an equation. Let's start taking the information and transferring it over here. Now I want you to put me on pause and see if you do this right. I want you to look at the information in this drawing and see if you can put it into these two triangles correctly. All right, again, if you haven't put it on pause, I want you to go ahead and do that. All right, let's go ahead and put the information. And of course, we'll just call the height of the tree x. All right, since it's similar, I get to write a proportion between their corresponding sides. Oops, yep, 3 over 30. And now it's just a matter of solving that. And when I do, I get 20. So, 20 feet high or whatever it is. That's how you're going to find the height of the tree. Go ahead and write your summary. Let's look at the do it problems. And I'll zoom them in so you can see a better look of it. Go ahead and put it on pause when you need to. Number 2 there is a review problem from chapter 5. Just checking to see if you know or remember how those triangles are congruent. Same here. And then this one is classifying triangles, identifying is it an isosceles, right, scalene, obtuse, acute, and all those things. Don't forget the 3 bears.